How many times have people reminded you to wash your hands lately? Probably a lot. I know I'm guilty of it. And there's a good reason why. There's a bit of a virus going around. I don't know if you've heard of it. But by now you probably know that washing your hands is really important. It keeps us safe, it cleans us up, and it makes for really happy spoons and forks when we eat dinner. But have you ever wondered how soap worked? There's like 50 different variations of it. Which one is the best and which one is the worst? Or are they all the same? That's what this video is about. Where soap comes from, the history behind it. After that, we're going to look into how soap is made and what it's made of. And then we'll finally look at some of the properties that make soap so special. So if you've ever been curious about soap, this is the video for you. Let's get started. So if you've ever been curious about... This was a bad idea. So first, how old is soap? Very, very old. So old that many anthropologists think it was one of mankind's earliest discoveries/inventions. It's so old that Romans have mythology about it. Not cool gods and goddesses or Rick Riordan books about Percy Jackson kind of mythology, but mythology nonetheless. It tells of a mountain called Mount Sopa where the Romans would make sacrifices to their gods, and after a hard rain, the women of the surrounding villages would notice that their clothes were much cleaner if they washed them in the nearby river. The Book of Job, which is the oldest book chronologically in both the Jewish and Christian traditions, mentions the use of soap as well. The translation literally means lye, which is a sort of animal fat. We'll get back to that in a second, that's a hint, so remember it. The archaeological digs of ancient Babylon have found clay pots filled with what appears to be soap dating back to 2800 BCE. So yeah, ancient history. Even once we started figuring out what went into soap, it took a while for people to start figuring out that it was actually good for you. Like Queen Elizabeth I was noted to only take a bath with soap every 4 weeks. Gross. So soap has come a long way for sure. And chances are you have about 5 different variations of it in your own home. So let's go into what the basics are in making soap. What is soap made of? Soap is a combination of acids and bases. An acid in science contains a positive charge like the plus sign on a battery. Bases in science are the opposite. They have a negative charge like the minus sign on a battery. When they come together as a result of a chemical reaction, they make a whole bunch of cool things, one of which happens to be soap. The most common bases for soaps in the past have been alkali metals, like the alkali batteries that you see, and animal or plant fat. Usually the metal comes from ashes. When we put these things together, usually by boiling them for quite a while, they undergo a chemical reaction that produces a cleaning agent that we call soap. But why so many soaps? You probably have like 10 different kinds at your house. Bar soap, dish soap, detergent for washers, antibacterial soap, soap special for your hair, and soap for everywhere else. So here's what all the suds is about. I'm so sorry. It's not funny. All soaps use a combination of an acid and a base. Different balances of those two put together have different effects. Some soap is really powerful and strong, but also dangerous, and some soap is pretty mild and doesn't clean too much. Even salt, like table salt, is a type of cleaning agent, though it's mild enough that you can eat it. This is a great place to mention this disclaimer, do not put unknown bases and acids in your mouth or on your skin. They can be dangerous and poisonous, and we don't want anybody to get hurt. Ask your parent or guardian before eating, drinking, or washing with any sort of chemical that you don't know, and only do so with their supervision. Mr. Kyle usually does his experiments with responsible and capable adults around, so follow his example. But soap is so special because the reaction that takes place is a super unique one. It gives it special properties that have effects on germs and bacteria and water, of all things. So what are those special properties? There are 2 important properties to soap that we are going to experiment with today. Number 1, soap and surface tension. You'll need water, a basin, some soap, and some pepper. Fill the basin with water and cover the basin in pepper. Then stick your finger in. What happens? Well, nothing really except for a wet and peppery finger. Now dip your finger into some of the dish soap and dip it back into the water. The pepper runs away. Well, why is that? Water tends to stick very well. All the water molecules on top stick together and create what is called surface tension. Objects that are really light, like pepper and sometimes bacteria, can float on the top of water without breaking the surface tension. But soap has a unique property which allows it to easily break surface tension in water, which causes it to snap back like a rubber band and pull everything on top with it. It works even better when you mix soap with 20 or 30 seconds of hand washing. The next property of soap is that soap attracts fats. For the next experiment, you'll need a basin, food coloring, soap, and milk. Whole milk works best. This one starts the same way. Pour your milk into your basin, then add a few drops of food coloring. Don't overdo it, a little goes a long way. Then dip your finger in. Nothing should happen. Now get those fingers all sudsy by dipping them into your soap and put them back in the basin right into one of your dots of food coloring. The food coloring should run away from your finger. Pretty cool, right?
Yeah, that was pretty cool.
If you think you know why this happened, pause the video and take a guess. I'll wait. Ready? If you guess surface tension again, you're almost right. Milk does have surface tension that soap can break, but that isn't what made the food coloring run away so fast. Milk is made of water, minerals, a little sugar, and animal fats. Soap works by attracting the molecules of fat in the milk. Since lipids, fats, are larger and lighter than other ingredients, they rush to your finger and push all others away, making it look like those other ingredients are running away. The fats in milk love soap, so they shove the other parts of the milk back. Why is this experiment important? Other than giving you a really good guide on how to clean milk, knowing that fats are attracted to soap is really important because usually fats and water don't mix. If you mix any oil with any amount of water, they will eventually separate. Because fats are hydrophobic, that means they're afraid of water. Our bodies produce natural oils all the time that serve as a protective barrier for us most of the time, but when germs arrive and stick to the oils on our hands or hair, sometimes we can accidentally wipe that oil off on our nose or mouth and give those germs a free ticket inside. When we wash our hands with soap, the soap has the opposite effect. It attracts the oils in our bodies, or leftover clothes, or leftovers from that greasy cheeseburger from dinner last night, and allows it to mix with water so that we can wash it away. If you ever notice your hands get dry after you wash with soap, it's because all the natural oils that make your fingers feel hydrated were washed away along with the germs. Without soap, the hydrophobic grease on our hands would just make all the water bounce off. But with soap, we're able to wash those oils and the germs off of our hands and keep us safe.
Back at the library. So hey, thanks for watching the video. Hope you really enjoyed it. Hope you learned a little bit about soap and the story of it and all that fun stuff. Go home, try some of these experiments yourself. Don't forget you're a responsible adult, and have fun. Stay safe, wash your hands. My hands are blue from food coloring. I'm gonna be blue forever. I'll see you next time. It's pretty cool.